SurfCam 2023.1 introduces shank collision checking as a new toolpath option. Let's take a look at the rules for this great new feature. Milling toolpaths have a new tool holder tab where shank clearance is controlled. Supported toolpaths will say shank in the options available at the top. The shank will not be collision checked if the shank diameter is the same as the flute diameter. Make sure the shank diameter is larger during toolpath setup. The shank clearance adds to the radial calculation of the shank size. Any moves where the shank would interfere with the part geometry are deleted. Here is a list of the currently supported toolpaths. Let's take a look at this new feature in action. In this example, we have two rectangular pockets being cut by 2D waveform toolpaths. On the left, we have a tool defined with equal flute and shank diameters. The collision checking will not occur in this toolpath. You can see the tool does not allow for any checking. When a larger shank diameter is defined, as the right-hand toolpath does, you see that the flutes are moved away to accommodate the shank. Now, to prevent the shank from contacting the part geometry, a clearance value can be introduced. Here are what the results look like by simulating the toolpaths. Next, let's take a look at this new feature interacting with surface geometry. The same rules as before still apply. You'll use one of the supported toolpaths, in this case, 3-axis Z-Finish HSM. With the tool shank defined as the same size as the flutes, the tool runs everywhere. Once the tool has been defined with a larger shank size than the flutes, the collision checking is engaged. To make sure the shank does not collide with part geometry, a shank clearance can also be defined.